talk about here is we talk about Jaz software and the different ways that you can communicate and talk to a Jaz and write new software for a Jaz. We'll go over a little bit of the architecture of how Jaz is laid out, what the software looks like that's running on it currently, and how it all interacts with the different ways that you can communicate with it. One of the first things about a Jaz is very complex software design. It's not trivial, it's pretty complicated. Most of oceanographic spectrometers don't really have a lot of software running on them. They're pretty easy things. You get a spectrum, you set some parameters, you get a spectrum. That's all you do. Jaz does a lot more, so it's very complex. It's got a powerful processor on it. It's running a Blackfin processor with micro C UC Linux running on it. It's pretty powerful. It can do a lot of things. State-driven design, we run for states so that you can do a certain amount of things while you can, and you kind of build on that. It's very flexible. You can pretty much do whatever you want with it, whether you're writing your own software especially. And it is Linux-based, as I mentioned before. It's UC Linux, so the actual Jaz is UC Linux-based. So definitions that we're going to use, there's something called a daemon. A daemon is basically just a task or a process or a program that runs in Linux. Everything that controls your PC when you're running Linux is called a daemon. It's basically there's a daemon that controls your screen, controls your keyboard, it controls your hard drive. All these daemons run in unison to make up your system. Jaz uses those and that concept of daemons since we're running Linux. API, which is an application programmer interface, and JSL, which is the Jaz Scripting Language. One important concept to know for Jaz is a socket. A socket is basically just a group or a module of information that can be passed between processes, or between programs, or between computers, or between anything other we do on the Jaz. So when you're running in the network, your PC sends sockets to the server sends sockets back to your PC. It's a predefined communication bundle, if you will, of information. A script. A script is a program-like set of instructions. It is not a program. It is a program-like set. It is interpreted by the machine that is running on it rather than running directly on the machine. So there's another piece of software that has to interpret that script in order for it to run on your computer. Same thing happens in a Jaz. A compiler. A compiler is another program that takes the code that a programmer will write and put it into assembly language so that it can run on a computer. It takes those, and you usually call that an object. You have all these little objects that you can create, little programs that you can create to run. If you want them to all run as one cohesive entity, you use a linker. A linker will link those objects together to make one object or one executable. So, the Jaz software architecture. Something in Jaz called dispatch. It's a daemon that is the main daemon that runs in Jaz. It's like the traffic cop. Everybody communicates with dispatch. Nobody communicates with each other. So this side of the room and that side of the room can't talk to each other. They have to talk to me. So if you have something you want to say to him, you tell me, I tell him, and I tell you back. So that nobody can do anything without my knowledge, which means if you do something that you shouldn't do, I can tell you no. Whereas he may say, okay, I'll do it. And I won't give you the permission. Dispatch is also the first daemon to launch when a Jaz boots. So it provides a point of contact for all daemons. So dispatch has to know everything. It won't let anybody not. Anybody that's there that doesn't talk to Jaz won't get talked to. That way nobody can sneak in and do things that you're not supposed to. Dispatch routes messages from one daemon to another, provides some other services such as listing all connected daemons and notifying daemons when other clients connect or disconnect. So when somebody leaves the room and he tries to talk to them, I say, they're gone. Or I can tell him as they leave. That way you don't have to. This is kind of a graphic representation of how that works. This particular daemon called GUI is the one that controls the screen and the keypad. So if you have a message up there that says get Spectrum, yes or no, and you press the yes button, it's going to send a message to dispatch. Dispatch is going to send a message to the spectrometer daemon. The spectrometer daemon is going to go get the spectrum, return it back to GUI, and GUI is going to decide what it wanted to do with it. If it wanted to write it to a file, it's going to say okay, and then we write it to the file through dispatch. So we're going to kind of, since that was just the broad overview of how the Jaz architecture is basically laid out, we're going to go over JSL versus OmniDriver versus the API and what each of them does and the differences between them. First one's going to be JSL. JSL is a very simple language. It's designed to be used by non-programmers. Everybody in here, no matter what your programming previous experience is, whether you have 0 or 10 years of it, within 20 minutes we could write a Jaz script that would get a spectrum and display it to the Jaz. Very easy. Very few lines of a script or of text or code, if you will perform a task. So if you're going to go get a spectrum, you just have one line to get spectrum and where you want it to be put. If you're doing it in another language, you may have to go through 4, 5, or 6 different commands to set different things up. Well, we set that all up for you. I've always used what I call the digital camera analogy. Everybody knows a little button on the top of the camera that has the portrait, landscape, person, the little different settings, and it sets the camera to certain things. That's kind of what this is. You have a function, we set the parameters for you. You don't set them. One of the cons is that Scripter has to have knowledge of every process and every data structure on the Jaz. So anytime something changes, Scripter has to change. It's very rigid. You can only do certain things. You can only do what we've determined or allowed you to do. You don't have full control of the Jaz. You have control of the things that we allow you to have control of and do them in the manner that we allow you to do them in. Any changes to the Jaz require a new version of the Scripter parser. Big example of that is Indy. Indy is now in the Jaz. You cannot control the Indy through Scripter because none of the commands to control Indy are in Scripter. So Scripter doesn't even know that Indy exists. The limited set of computational operations, limited math functions. We do addition, subtraction, multiplication, division, cosines, logarithms, those kind of things. No real fancy math, simple basics. Same with spectral math. You can add, subtract 2 spectrums, you can do that kind of thing, but nothing fancy, and it's a lot slower. So graphically, you've got a remote PC, and you've got your Jaz stack. Within the Jaz stack, there's an API and Jaz Scripting Language. So those run. And then you've got your daemons that run. This is all running, and those are all communicating with each other. Is running back and forth. These are all doing what their little things that they do. And then within that, there's a predefined set of commands that are part of the API. You notice it's only part of the API, it's not the entire API, it's only a small portion. And what happens is JSL talks to those predefined commands, the ones that we have determined are necessary, the ones that we say we allow you to do. Those commands then talk directly to dispatch. So now, when you want to get a spectrum, you say get spectrum. It goes to here. It gets interpreted. It gets translated. It then gets sent to dispatch to get a spectrum. Dispatch goes to the spectrometer, comes back, and then back to you. So now you got 1, 2, 3, 4, 5, 6 steps to get a spectrum. It's not going to be all that fast, is it? Now, I think if you're doing something complicated, how slow that's going to be. So you do have the PC. Now you do have the ability to run Scripter on your PC. And when you're programming and when you're creating your script, you're going to want to run Scripter on your PC so that you can see any errors that you have. So if you spell something wrong and you're running it directly on here from your SD card, it's just going to stop. It's not going to tell you anything. You're just going to have a blank screen and it's not going to do anything. You're going to wonder why. You're running it on your PC. Your PC's talking to this. Now you're going to get an error message back on your PC that says you have an undefined variable. And you're going to, oh, look at that, I spelled count wrong. So you can go back, correct it, and then rerun it, and now your program works. Now your script runs. So when you're developing, you're going to be running on your PC. And you're communicating through your stack. And it's just like you're running on the stack. Everything happens on the Jaz, the buttons you use on the Jaz, the displays on the Jaz, everything's done on the Jaz, but your script is running on your PC and you're able to get error messages back. What types of applications? Simple. Things that don't require a lot of data, don't require a lot of math. So for prototyping an application or proof of concept, something that you think you want to do, you can write a script real quick. Say, yeah, I can do this, and now I can go in and do it a different way and make it prettier, make it a little more user-friendly. Fixed application, something that's going to repeat the same thing over and over again. Doing the same thing, and it's something simple. Doing the same thing over and over again. Automation of simple tasks in the field. You got something that's written, you want somebody to go out and take a spectrum and save it to the disk, but you want them to get 10 readings. He goes clicks, 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 clicks. You can do that in Scripter real easy. Lightweight calculations, nothing heavy, nothing really math intensive, because the math power is just not there in the Scripter, because we don't give you the math power. The math power is there on the Jaz, but it's not there in Scripter.